Why are deadlocks a problem for data integrity? Have you ever wondered why deadlocks can be such a headache for software developers? Let's take a closer look at this issue and how it impacts data integrity. Deadlocks happen when two or more processes are waiting for each other to release resources, causing them all to be stuck. This situation can lead to serious problems for data integrity. When deadlocks occur, transactions can become incomplete or inconsistent. This means that the data might not reflect the true state of the system. In database systems, locks are essential for maintaining data consistency. They prevent conflicting operations from happening at the same time. However, when a deadlock takes place, the database management system must choose a transaction to roll back. This rollback undoes changes made by that transaction, which can disrupt the normal flow of data updates. One major issue with deadlocks is that they force the system to abort transactions. This can lead to the loss of important data changes. Developers then have to manage retries or other actions to keep the data in a correct state. If they try to bypass locking mechanisms, they might end up reading uncommitted or inconsistent data. This is known as a dirty read, and it can directly harm data integrity. Frequent deadlocks can also slow down application performance. They create delays and reduce the overall throughput of the system. This can increase the time that data remains in an inconsistent state, especially if transactions are long-running or repeatedly aborted. Debugging deadlocks can be quite challenging. They often depend on specific timing and concurrency conditions, making them hard to reproduce. Without proper monitoring tools, it can be tough to pinpoint the exact cause of the deadlock. This leaves risks to data integrity unresolved. To effectively manage deadlocks and protect data integrity, developers can take several steps. Keeping transactions short and simple can help minimize how long locks are held. Optimizing queries and indexes can reduce lock contention. It's also important to use the right transaction isolation levels to balance consistency and concurrency. Designing data access patterns to avoid cyclic locking dependencies is another effective strategy. Monitoring tools can help detect deadlocks early and analyze their causes. Finally, handling deadlock exceptions in application code by retrying transactions when it is safe can also be beneficial. In summary, deadlocks pose a significant threat to data integrity by causing transaction rollbacks and inconsistent data access. Understanding how to debug and prevent them is essential for maintaining reliable software systems that manage concurrent data operations effectively.